How do you find vertical asymptotes? Look at when the denominator equals 0 and the top does not, right?
2 and negative.
Good. 2 and negative 2. Everyone agree? All right, so done. I could answer the question right there and get it right. Correct? Because there's only one answer. But let's go ahead and talk about horizontal asymptotes. Evidently, there's one at +2 and at -2. Using calculus, how do you find horizontal asymptotes?
Limit.
You look at the limit as x approaches
1.
infinity, and as x approaches negative infinity, right? And as x approaches infinity and negative infinity, that first piece takes over. As x approaches positive infinity, y approaches 2. Everyone agree? But as x approaches negative infinity, y approaches -2. So there are 2 horizontal asymptotes. To the right, there's a +2 horizontal asymptote. To the left, there's a -2 horizontal asymptote. Any questions about that? Just a random fun question. What's the domain of f of x?
Negative. No.
What do we have to be careful about? 2 things. Undefined places. And what are 3 things? There's 2 big ones and then a third one since you're so smart. Well, 4 if you add trig. What are places we look that are undefined?
That are negative on the bottom.
Denominators can't be
0.
0. What can't be negative? Something can't be negative.
Inside
of a square root can't be negative. For our problem, that's the only 2 that matter. Logarithms can't be 0 and negative, and then trig functions, you have to watch for denominators on trig functions as well. So,
starts off with
x plus 2, x minus 2 needs to be strictly greater than 0. Has to be positive, and it can't be 0. Right? Well, we can do a quick sign chart.
No.
Oh, it won't take us long.
We're like
No, we are.
everything that we have learned into one spell word. It's called math.
Yes. It's about to be called calculus. That is the hardest part about calculus, is that everything is important that you've ever learned. Like 5th grade math. -3. Negative times a negative gives me a positive. Negative, positive. So the domain is negative infinity to -2. 2 infinity. Any questions about that? Okay, that was fun. This is just a calculus joke. Don't write it down.
Whoa!
Don't do that. All right. All right. So what we want to do is use limits to get a formal definition of continuity. Does anyone have a not so formal definition of continuity? Okay, what is the definition of being continuous? What does it mean to be continuous?
Never end. Infinite.
always.
The continent is a large area.
The universe.
What does it mean to be continuous? So some of you said it keeps going. Okay, so is this continuous?
Oh, yes. That one.
It keeps going?
Yeah. But it stops.
Why is it not continuous?
It stops. It's not constant.
Okay, it doesn't have a break in it. In fact, in Algebra 1, your Algebra 1 teacher probably told you a function was continuous if you could draw it without picking up your pencil. Right? Y'all remember that? In fact, that's the only definition you have of continuity. Do you think you'll ever see that in a math textbook? You can draw it without picking up your... That's not very mathematical, right? So, why have you never learned a definition of continuity?
Because it's chair.
It's actually pretty complicated to explain, isn't it? It keeps going. What does that mean?
There's no breaks.
What's it?
Holes.
There's no breaks or holes, maybe? Okay, turns out the real definition of continuity involves limits. That's why you've never seen it before. It's not that hard, it just involves limits. And it's a three-part definition. So I'm going to start it for you. A function f is continuous at a point at x equals a or c or whatever you want to call it, if and only if. Have y'all ever seen the double F before? It stands for if and only if. Part 1. So you tell me, using limits, what would have to be the case for a function to be continuous at a point A? If and only if. It's like using limits. Okay, if it doesn't D and E. So tell me, help us out a little. I like that. If what's it, first of all? The limit as x approaches a of the function. If it doesn't D and E, I'm just going to undo that double negative and say exists. Yes. If it doesn't not exist, I like it. But
If it jumps, but it still does every point, is it still continuous?
no. Because if the limit as x approaches a doesn't exist and at a jump, it wouldn't exist.
I mean, one of us filled in the other one.
Does the limit exist at a jump? Okay. A function, good question, but a function by itself, and if we were writing this slightly better, we would have said a function f, so we're already covered with that, but good question. 2. Okay, so first I said the limit must exist. Does that guarantee continuity? Why not? There could be a hole, right? So what else has to exist?
No holes.
Okay, at A there can't be a hole, right? There has to be a dot there, right? Well, we need to say that a little bit more mathematically.
It has to be a coordinate.
F of A has to exist, right? We have to have a point at the A value. For it to be continuous at A, we have to have a point there. You see why 2 parts isn't quite enough. So we got a point, we got a limit.
Something about asymptotes.
Yeah. The limit existing throws out asymptotes.
Okay.
Hey.
Look at my test.
Okay, I need your help. The limit exists. The point exists. What would make it continuous, though?
If you can't pick up your kids.
Okay, the limit exists. The function exists.
There's a point. Out.
4 points on the graph.
Right here. I want to talk about continuity. Right here. What'd you say, Paxton? Yeah, those 2 things have to be the same to be continuous, right? got to be the same. Thank you. So last thing, the limit as x approaches a of f of x has to equal f of a. You have to memorize this. All three parts, all of it. You have to memorize it. The reason you have to memorize it is on the AP exam, they may ask you if a function is continuous or not, and then they may say this word that you will grow to hate, justify. Well, to justify something, it's kind of like a proof. You have to prove something. And we have to go back to a definition and say, well, the limit exists, f of a exists, they're the same, so therefore it's continuous. So you will see that soon.
It looks like you have two exists.
Okay, this is the official definition. You came up with it with a little prompting from me. But a function f of x is continuous at x equals a if and only if the limit exists, f of a exists, and they're the same. Okay? This is what we are learning about today and tomorrow is continuity. And this is our formal definition of continuity. You can see why you haven't learned it before because you didn't know what a limit was. But continuity is very, very difficult to explain. As easy as a concept as it is, it's difficult to explain because it involves infinitely small connections, right? A function is continuous if it's continuous at every point. So that's where we could get a full definition of continuity. So a function is continuous if it's continuous at every point. All right. So let's do some AP questions. That's essentially the new stuff for the day, is the definition of continuity. We just need to work with it a little bit. Yeah.
You don't have any homework, right? No.
Yeah, you have homework.
No.
You always have homework. You always have.
We did last night.
I made some up. Remember, I'm like, oh, you don't have homework. Here's you some papers. See? And we always have homework. Always something to learn.
So we have.
So our homework is memorized.
He's talking about my double negative. Here's you some papers.
Okay.
Do you hear this?
All right, let's look at these AP problems. I can make that bigger, I think.
Oh.
No, I can't. He may not watch this video because I gave him the link so he could watch it last night from spring. So, because you'll know that little Word document at the top of your videos. It actually has every video from this semester on it. So if you're gonna miss a day, you could actually now watch it before you left if you wanted to.
Why watch it from the past when we can watch it from the other day and experience it?
Because you could watch it early in the. If you're gonna be busy, you might want to. Okay, try this. I'm going to read it to you. The graph of a function f is shown above. If the limit as x approaches b of f of x exists, and f is not continuous at b, then b equals what? So, the graph of f is shown above. The limit as x approaches b exists, but it is not continuous. So you might need to think about what that means would have to fail if the limit exists, but you're not continuous.
Two.
There's a hole, right? Because if the limit exists and we're not continuous, doesn't that mean the filled-in point is somewhere else or doesn't exist? Okay, so where does that happen at?
2.
Some of those answers are right. Just 0. Why just 0? Okay, at 2, does the limit exist at 2?
Yeah.
Or not.
No! At 2, the limit from the left is 2, the limit from the right is 1. That means
You have to be more specific with which two.
No, I don't. What's approaching 2? X is approaching 2, right? What kind of 2 is this 2?
Y.
It's a y2, not an x2. The limit as x approaches. Yes, we said x. They were saying that this was the 2, but that's not x approaching 2. That's a y. Yeah, that's 0. So the limit does not exist here, right? Does the limit exist back at -1?
No.
No. Does the limit exist at 0?
Yes.
Yes. So 0 is the answer. Okay, let's look at the next one. You don't know what differentiable means, so I will answer that part of the question for you. But I want to know if the limit as x approaches 3 of f of x is 7, which of the following must be true? And I will tell you 2 is not necessarily true.
So 3 is true, for sure.
The limit as x approaches 3 is 7.
So it's
The limit is 7.
D.
I want you all to think. The limit as x approaches 3 of f of x is 7. Which of the following is true? And I'm telling you that it's not necessarily differentiable. And we'll talk about that word later. It's not. Does the limit being 7 guarantee anything about continuity? Why not? I get a hole, right? So the limit existing is not enough for me to know that it's continuous. Agreed? It's not enough. Does it guarantee that the function equals 3 or equals 7? Does it? Yeah, no. The limit existing tells me nothing about 3, right? Tells me what's going on around 3. At 3, I don't know anything about that. So, no. So, is the limit existing the same as something being continuous? No. That's one of the most common mistakes in calculus, is to think that a limit existing means that we are continuous, and it does not. Next. Use the definition of continuity, and so I'm kind of using this because it didn't take me real long to teach this, to review piecewise functions as well. So we're going to double continuity and piecewise functions. Use the definition of continuity to determine if the following functions are continuous. Okay.
So just draw a diagonal line from 0 to.
All right, so the first thing I'm going to do, I'm going to start by graphing. At some point, I will quit graphing because I don't need a graph to answer these questions. But for now, I'm going to graph. When x is less than 0, I have the line y equals x. So from here back, I have the line y equals x. And then from here on, I have a parabola, x squared. At 0, what's the parabola? 0. So now that I've drawn the picture, is this continuous? Yes. Now it doesn't say use the picture to determine if it's continuous or not. The first thing I would do is look at x and x squared. Do both of those have limits everywhere by themselves? They're both nice, pretty continuous functions by themselves. So if this weren't continuous, where would it be not continuous at? At 0. Now, this does not ask me to prove. I'm going to pretend it did just for a minute to show you what that would look like. If I wanted to prove that this was continuous at 0, I would say that the limit as x approaches 0 from the left of the function is 0. because that's this top one, right? Everyone agree? The limit as x approaches 0 from the right, again, for this particular problem, this is way overkill, equals 0 squared, which is still 0. So that means the limit as x approaches 0 exists, and it equals 0, right? What is f of 0? 0 squared, which is 0, right? And what do you notice about those two things? They're equal. So that's how you prove something's continuous. You show the limit exists and show that it equals the function value. Again, way overkill on that one. From now on the rest of these, I'm just going to answer the question. I'm not going to do a proof. I'm going to answer the question. Okay? I'm going to go ahead and practice graphing, but I'm going to show you on these how I wouldn't have to graph. What do I really want to know? This is a line, this is a parabola.
If they have the same meeting point.
If they meet at the same place, right? They both get to the diner. So I want to know if the left-hand side of this equals the right-hand side of this. We do have a filled-in line, so if the left equals the right, then we're good to go, because the limit would equal the function value. What do I get if I plug in 3 into this one? 5. Open circle, and it is a line, slope of 2, looks like that, right? To the right, what do I get when I plug in 3? 0. Is this continuous? No. It's not continuous at 3. Why not? The limit from the left and the right are different. If I were proving that something was not continuous, would I have to do all 3 parts? No. As soon as one part doesn't work, I am done. It's called a counterexample. Those of you who took geometry remember some things about geometry. It's called a counterexample. Okay, I'm going to go ahead and graph this one. Again, completely unnecessary. I don't need to graph it. I can answer the question without graphing it. To the left of 3, I get 2x minus 1. Everyone agree at 3, that's 5 again. That's the same. I've already drawn that line once. At 3, the function is 15, right? Way up here. Farther up than that, but that's as far as I can go. From the right, if I plug 3 in, 3 squared is 9. 9 minus 4 is 5. So does it pick up right here? But is it continuous? Why not? And what is my real reason it's not continuous? The limit as x approaches 3 of f of x is what? 5, which is not 15. That is not the same as f of 3, which is 15. So the limit and the function value were different. Does everyone see which case that failed? Okay, this is a very common calculus question on AP problems. If f of x is this piecewise function, and it is continuous at every point, then what must a be? So it's saying it is continuous. What is a? Any ideas on an approach for that? Okay, plug in 3 where? For x in both of them? Okay. So f of 3, right, is 3a minus 5, 3 plus a. There's really really f of 3 is just 3 plus a, but we'll go with it. To make this continuous, those two things need to be equal. So 2a equals 8. Am I going too fast on that solving? So a must be 4. Check it. 4a minus 5 and x plus 4. If I plug in 3 into both of those, do I get the same thing? Any questions about this one? So, does everyone agree continuity is a pretty easy concept? I mean, easy enough you learned it in Algebra 1, but in its technicalities, it gets a little tricky. Everyone kind of see how that works, so that's why we're picking it back up now. Try this one. It is a non-calculator question, by the way. No calculator. I'm going to pass out two things. I have the copier reprint. You remember that thing I passed out yesterday that some of you were missing pages? I had it reprinted. You may have to transfer some answers over, but this one has all the pages on it. So that's, and then this little one-page thing is your homework for tonight. This still isn't due until next week sometime. I'll give you a due date on it when it gets closer. Just grab one of those paper out. Okay, natural log of x. In calculus, you're never going to be asked to graph by hand, but you will be occasionally expected to know what a graph looks like. And here is that example. Do we know what natural log of x looks like? We know it's the inverse of an exponential, right? What's natural log of 1? 0, how do you know? A logarithm of 1 is always 0, right? Because anything to the 0 power is 1, right? You need to memorize that, by the way. So is a logarithm continuous? At 1. Where is a logarithm not continuous? Negative numbers or 0, right? But we've got issues at 0 and negative numbers. We are fine at 1. E to the x. We're fine. E to the x is continuous everywhere. It's not one of the 3 problems, right? Logarithms could be problems, right? The inside of the logarithm can't be 0 or negative, right? What's e to the 1? E, which is about 2.7, right? What's 2.7 minus 1? Not 0 or negative, right? Good, good, good. So that took some, the effort in that problem was the algebra, was remembering logarithmic properties. Video. Okay. Any questions for me? You have 15 minutes left in class. Do some homework. Do what? That is, remember that thing you got yesterday? Yeah. There was missing pages? Yeah. That's it. Without missing pages. Throw the other one. Transfer your answers. Throw the other one away. That's a good one. Other than that, it's the same thing you got yesterday.